Hi there. Today we're starting Chapter 4. Chapter 4 is on atomic structure. Chapters 4 and 5 go together. While in Chapter 4 we're going to talk about the general structure of an atom and a little bit more about the mass of the atom, which means we'll be talking about protons and neutrons. Chapter 5 goes into a lot of detail about the electrons. So we sort of split up the concept of the atom into two separate chapters. One focusing on the nucleus of the atom and the mass, and then Chapter 5 all on the electrons. So we're going to do this in a little bit different order. If you're following along with the textbook, we actually start this chapter with section 2, which says the structure of the nuclear atom. 4.1 is a lot of the history of how we came to know what is inside of an atom. And so if you want to read the textbook and learn more about that, it's really interesting, but it's not necessary for us to continue on with chemistry. So the first learning objective is to identify the subatomic particles in an atom. And these, I believe that you know from elementary school and middle school, that inside an atom there is a nucleus. The nucleus is at the center of an atom. It contains the protons and the neutrons. And then outside the nucleus there is what we call the electron cloud. And surprisingly, the electrons are located in the electron cloud. The charges and relative size of those particles are really important. So an electron is negatively charged, a proton is positively charged, and a neutron has no charge. It is neutral. And of those three particles, an electron is much smaller in mass than a proton or a neutron. Right below that, you have this table with the properties of the subatomic particles. So we use that word subatomic to mean particles that are smaller than an atom. So collectively, protons, neutrons, electrons. And you can see here the symbols that we have for them with a lowercase e, n, or p, and then in the upper right-hand corner, their charge, their relative charge, and their relative mass. And if you look at the relative mass of an electron, it is incredibly small compared with that of a proton or a neutron. The largest atom that there is only going to have 118 electrons in it, which, you would need 1,840 electrons to equal the mass of one proton or neutron. So we're going to go through these doodle notes. Remember, color these in, make them, fun any way that you want, through the different parts of the atom. Just more information about the nucleus, more information about those three subatomic particles. So the first thing that we're going to just talk about is in general. And we're going to fill in the box in the upper right-hand corner of this sheet. That all matter is made of tiny particles called atoms, and that atoms are made of even smaller particles. We call them subatomic particles, and those are called protons, electrons, and neutrons. So this picture here shows us just a schematic of what an atom would look like. In reality, the nucleus of the atom, where the protons and the electrons are located, is incredibly small compared with the electron cloud surrounding it. So we are really blowing these up completely out of proportion, just to give us an idea about in concept, sort of what an atom looks like. So inside the nucleus, so that's the center, you will see that I shaded the protons sort of a red color and the neutrons a green color. So let's talk about what protons are. Protons are positively charged particles in the nucleus that have a mass of 1 AMU. The number of protons determines the The number of protons determines the element of an atom. For example, hydrogen has 1 and helium has 2. When we talk about, what makes an atom of oxygen oxygen, it's not the number of neutrons in its nucleus, because that can vary, and it's not the number of electrons that it has. It is the number of protons. If for some reason an atom changes the number of protons in its nucleus, then the identity of that atom changes. So, for example, if oxygen loses a proton, it becomes nitrogen. If you are doing anything like that, you're changing the structure of the nucleus. That's not a chemical reaction. That would be what we consider a nuclear reaction, because the word nuclear reaction is literally referring to a change in the nucleus of an atom. So now we have the two other subatomic particles. Let's look at what's symbolized here in green, because that's the other particle in the nucleus. Sometimes you might hear them called nucleons. That's a collective word for protons and the neutrons, because they're both in the nucleus. So a neutron, also in the nucleus, has a mass very similar to that of a proton, not exactly similar, but to a certain number of significant figures, they're the same, but it has a neutral charge. So a neutron are neutral particles in the nucleus of an atom. They have no charge and have a mass of 1 AMU. Hydrogen is the only element that does not have at least 1 neutron in its nucleus. Hydrogen is really unique. So those are the two subatomic particles in the nucleus, and then outside the nucleus of an atom, you have the electron. The electron is much smaller in mass than that of a neutron or proton, and it has a negative charge. It has an opposite charge of that of the proton. Right? I colored them in here in blue, and you can see that they are in what looks like rings. We're going to be calling those energy levels. We're going to go into way more detail about electrons in the next chapter. So let's write down the notes about electrons. Electrons are negatively charged particles in the electron shells or the energy levels. The mass of an electron is about 1,850th of that of a proton. So it does not add significant mass to that of the atom. Now, we've used the word AMU a few times here when we've talked about the mass of a proton and the mass of a neutron. We've said it's equal to 1 AMU. We'll talk more about what that is, but it is an acronym that stands for atomic mass unit. Basically, if we were to use grams to measure the mass of a proton or a neutron, it would be a very, very, very small number of grams. You can see that on the table on our previous page. Okay. So down here, you have just an idea about trying to get us to wrap our brains around how big an atom is, right? Atoms are so small, the dot on this eye contains about 1 trillion atoms. Atoms are very small, right? That's why we need to use Avogadro's number so often. So what does that mean? Well, everything is made up of atoms, and atoms have the protons and neutrons inside the nucleus, and the nucleus is incredibly small compared with that of the electron cloud. So therefore, atoms are actually mostly empty space. And the mass only comes from the protons and the neutrons, just doing the symbols there, in the nucleus.